So 5.7, we are graphing inverses. So remember, inverse is just the roles of x and y have switched. So things have inverted or reversed. So if I look at this first point over here to the top left, that's negative 5, 7. So this top point, negative 5, 7. Okay, so at negative 5, 7, the inverse is going to have 7, negative 5. So 7, negative 5 is right here. Okay, so that's 7, negative 5. The next point I see is what? Negative 3, 6. So negative 3, 6. So I'm going to need 6, negative 3. So 6, negative 3 is right here. And then I see negative 1, 3. The inverse will have 3, negative 1. And then I see the point 1, negative 2. So I'm going to need negative 2, 1. Negative 2, 1. Okay. So if I draw this function, it starts down here. So we do something like this. So that is the inverse function. Okay. So let's answer questions. They're asking us about the domain of G inverse. Okay. You know that's the same as the range of G. So you can either get that answer from G or G inverse. If I look at G inverse, which is the red graph that I drew, its domain, so if I travel left to right, the domain is from negative infinity, and the highest x value I see is 7. So negative infinity to 7. And in the range of G inverse, y values for that red graph. So I don't see any y values until I get to negative 5, and it looks like those are going to go to infinity. Okay. And remember, the range of G inverse is the same as the domain of G, because x and y simply switch roles. Now let's look at the next one. So to graph this inverse, you basically pick points and then find the inverse of those points. So 1, 1, 2, 3, this is the point 3, 4. So I need to go find the point 4, 3, which is right here. Over here, I have the point negative 3, 2. So I'm going to need to find the point 2, negative 3, which is right here. Down here, I have the point negative 7, negative 6. So I need to go find the point negative 6, negative 7, which is right here. So if I connect these together, I get something that looks like this. The domain of H inverse. So the red graph that I drew is H inverse. Its domain, I get x values from what? Negative 6, which is right here. So the domain goes from here to here. That's negative 6 over to 4. The range of that red graph, I get y values that go from here to here. So y values are from negative 7, and the highest one I see is a 3. Okay, so negative 7 to 3 is the range of H inverse. So just keep straight the function and its inverse. We flip the role of x and y, and then you should be able to look and find the domain and range. Now, in set notation, I give you a relation, and I ask for its domain and range. Is it a function? Is it one-to-one? So the domain, this is just the set of all the input or x values. Negative 1, 0, 1, 2, 3. So I'm just copying down the first coordinates. Range, I'm going to copy down the second values. 2, 1, 2, 4, 7. If you were to write 2 down twice, that's okay. Doesn't matter. So 2, 1, 2, 4, 7. Is F 1-to-1? Okay, when it's 1-to-1, you're asking yourself, are there any repeated y values? Okay. Are there any repeated y values? If I have repeated y values, it's not 1-to-1. So you can see that if I look at my y values, The 2 is repeated, so this is not one-to-one. Is this a function? Remember, for functions, I'm asking, are there any repeated x values? -1, 0, 1, 2, 3. It is a function because there are no repeated x values. Find the inverse. The inverse just says flip everything around. So instead of -1, 2, you're going to have 2, -1. Then you'll have 1, 0. You'll have 2, 1, 4, 2, and 7, 3. And if I look at that, is that a function? This is not a function because it has repeated x values. Remember we talked about it. If a function is not one-to-one, then the inverse is not a function. Okay? So you can memorize that or just work with it, and you can tell just by looking at the data that this is, yes, it's a function, but it's not one-to-one. That means when I create the inverse, if I've got repeated y values in f, when I invert it, I'll have repeated x values in the inverse. So that's what makes the inverse not a function. The next one, we may not have done a problem like this. This is just using concepts of what you know. Add a point to f of x to make the function not one-to-one. So not one-to-one means it has repeated y values. So I've got to put something in that empty box that is a repeated y value. So it's either going to be an 8, a 3, a 5, or a 9, your pick, okay? So you can write either 8 or 3 or 5 or 9. Any of those numbers will work. So I now have repeated y values. That makes the function not one-to-one, okay? Now, another question. Add a point to f of x to make it not a function. If it's not a function, that means it has repeated x values. So repeated x values. I've got to take one of those x values that's up there and repeat it. So it can be, I can either put a -2, a -1, a 0, or a 1 in that box. So repeat an x value. So it could have been either 1, -1, 0, or -2. Any of those numbers would have worked as an answer for that. Okay? That is the end of that page, which is, what's that, page 1 of the review, and we'll come back for page 2.